that avoids dependencies altogether. Here we go. So before we can start talking about dependencies, we have to talk a bit about what is a dependency. Right? So what does it mean to say that our code depends on something? Well, our code doesn't automatically run on any platform that we choose. We don't just write some text and then the phone reads that text and does what we're telling it to do. There are a few steps along the way. So what are these steps? What kinds of things do we depend on? Well, there's a lot of things. Depending on what we're going to do, depending on what kind of code we're writing, the code can depend on a compiler in order to become a machine code that can run on the device. It can depend on the device's SDK and its native libraries. It can depend on the compiler's standard library. And it can also depend on third-party libraries, so libraries that you find on GitHub and that you use for different functionalities in your code. So a dependency, we can say that all of these things are dependencies, but we can also say more precisely that a dependency is anything that our code needs in order to be executed. So anything and everything that our code needs in order to execute, in order to run on the device, we're going to depend on that in order to run our code. So we call it a dependency. All of these things are dependencies, and even more things are dependencies that I'm not going to talk about today. In particular, if we look at this list, we notice that not all dependencies are equal. So some dependencies are more important than others. For example, if we take into consideration third-party libraries, so things that we found on GitHub and that are useful for our code, we'll probably think that we don't depend on these that much because these aren't that hard to replace if we had to. If we have like a third-party library in JavaScript that handles colors or something, there are probably a few libraries that handle this, or they handle network code, or they handle databases. There are probably several libraries in the most famous languages that deal with these kinds of day-to-day tasks. On the other hand, if we consider a compiler is a lot harder to replace. Especially a compiler that takes as input our language, the language that we're using, and a compiler that targets our platform. So there aren't that many compilers that compile Swift code to iOS, or they compile Java code to Android. So with this, we can see that some dependencies are more dependencies than others. And the way that we phrase that, the way that we think about how much we depend on something, it depends on how hard that thing is to replace. So a compiler is very hard to replace, but third-party libraries can be pretty easy to replace. And this is how we measure how we depend on each of these things. So now that we have a sense of what a dependency is, let's think about it in the realm of cross-platform tools. So how much do we depend on our cross-platform tool when we're creating a cross-platform app? Well, the basic answer is it depends on the tool. Because depending on the tool, it can be harder to replace or easier to replace. So let's look at some tools and let's take a look at each one, how they're structured, how they're used, and how hard they are to replace. If we think about famous tools nowadays, we'll probably come about with a list that's something like this. I didn't look it up on Google. I didn't really have a comprehensive list, or probably several other cross-platform tools that I'm leaving out of this. But these are just some of the most famous ones and some of the ones that we're going to talk about today. Now you may be thinking, why is it important for us to analyze how much we depend on these tools? Well, that was a problem actually that was documented a few times by big companies that used approaches like these ones. So for instance, Facebook in 2012 had to do one of these migrations. They were using a cross-platform tool and they had to migrate out of it. And it took them a long time. And Airbnb faced a very similar situation in 2018, Uber also faced a very similar situation recently. So this isn't just a theoretical problem that we're seeing. This is a problem that many companies have already faced, and these are just the companies that we know of, right? These are the companies that faced this problem, that talked openly about this problem, that documented the process that they were doing, that they were using. There are probably lots of other small companies out there that face similar problems that we're never going to know about them because they're just not famous enough to catch our attention. So let's take a look at how we can analyze the dependency of these tools. The best way to do that is by separating them into two categories. So on the left we have tools that use third-party languages, and on the right we have tools that use first-party languages. So for our purposes, first-party languages, we're considering anything that runs natively with an Apple or Google sponsored compiler, let's say. So we're pretty much just considering Java, Objective-C, Swift and Kotlin, C, C++, Objective-C+, if we're stretching it a bit, but that's pretty much it. Anything else is a third-party library is a third-party language for our purposes. So if we think about React Native, for example, React Native mainly uses JavaScript code. So that's a third-party language. Flutter uses Dart code. That's a third-party language. Xamarin uses C# code. That's a third-party language. All right. The cross-platform tools on the left all have several things in common. They have several things that are different, but for our purposes, they have several things in common. So we're going to use for now React Native as an example. But just keep in mind that the things that we say right now about React Native apply to all of these tools on the left. All right, let's get into it. How do we develop an app using React Native? Well, the first step is we write some JavaScript code using the React Native runtime, using the React Native libraries, etc. And then the React Native compiler, let's say itself, turns our code into something that can run on iOS and something that can run on Android. All right, so we basically depend on the React Native compiler to do all this transformation, to do the transformation that turns our code into an iOS app and into an Android app. And that's a problem because if we ever wanted to stop using React Native, if we removed it out of the equation, we wouldn't have any way to turn our JavaScript code into an iOS app or an Android app, right? We'd be stuck with JavaScript code that we can't run on either platform, and we'd be unable to use our code to do anything else. That could happen if we just wanted to change React Native for something else. So if we wanted to migrate from React Native to Flutter, for example, we would have a lot of trouble because as soon as we stopped using React Native, we would no longer have access to any of our JavaScript code. And it could also happen if this wasn't our decision. So for instance, if React Native stopped being maintained, eventually there would be bugs and it wouldn't support the latest version of iOS and Android anymore. And someday we would be forced to stop using React Native. And when that day came, we would have to do the same migration that Airbnb did, for example. So we would have to basically rewrite our whole application in using some other cross-platform tool or in some other way in order to keep developing it and keep maintaining it and keep updating it. So because we can't do anything with our code without React Native, our code is just text. It just can't be executed in any other platforms. We say that our code depends 100% on React Native. So this is a complete dependency. And this is the same not just for React Native, but also for Flutter, for Xamarin, for Ionic, for NativeScript, and for basically any cross-platform tool that uses a third-party language like JavaScript. Because we can't execute this language directly in any of the platforms. But this would be different if we had a first-party language. So let's see an example of a cross-platform tool that uses a first-party language. let's take a look at how Kotlin native works. So Kotlin is a language that runs natively on Android. So there's a Google-sponsored Kotlin compiler that can turn Kotlin code into an Android app, just like Java, etc. And there is also a Kotlin compiler called Kotlin Native that can turn Kotlin code into something that Android can run, or sorry, something that iOS can run. So we can use Kotlin Native to develop an app using only Kotlin code. That app then gets turned into both an Android app and an iOS app. So what's the problem with this approach when we think about dependency? Well, we no longer depend on Kotlin Native to develop our Android app, right? If we wanted to stop using Kotlin Native, then we would be left with Kotlin code that we can still compile into an Android app, but we still depend on it to develop our iOS app. So this is pretty much, we've halved our dependency, right? Now we just depend on it for one platform, but we no longer depend on it for both platforms. And why does this happen? Why do we still depend on it for iOS? Well, it's mainly because Kotlin Native generates a binary, right? So Kotlin Native turns out Kotlin code into a binary library that can run on iOS. However, it doesn't really have to be like that. What if instead of generating a binary library for iOS, Kotlin Native generated code? It generated Objective-C code or Swift code or any other code that can run on iOS. Then we could keep developing, without Kotlin Native, we could keep developing our Kotlin code for Android, and we could keep developing our new code for iOS, and we wouldn't depend on it anymore. That is almost what we get when we use another cross-platform tool called J2Objective-C. So J2Objective-C, as the name suggests, is a tool that turns Java code into Objective-C code. So it translates Java into Objective-C. So what's the advantage of that? Well, Java can be compiled natively to Android, and Objective-C can be compiled natively to iOS. So we can use J2Objective-C to turn our Java code into something that can run on iOS, and if we ever wanted to stop using J2Objective-C, we would be left with Java code that can compile to Android and Objective-C code that can compile to iOS. So how does this stand in terms of dependency? Well, we no longer depend on it for the Android code, but we still somewhat depend on it for iOS. And to see why, we have to look at this Objective-C code that J2Objective-C generates. So let's take a look at it. Let's take an example. Let's say that we want to analyze an empty class called hello. This is what it would look like in Java. If we were to write by hand an empty class for Objective-C, it might look something like this. So it's a bit larger because Objective-C is a more verbose language, but this is essentially the Xcode template. This is basically just an empty class called hello in Objective-C. This is written by hand, but if we were to generate it using J2Objective-C, if we were to translate this Java code using J2Objective-C, we would get something more like this. So you can immediately see that this is a lot harder to understand. It's a lot harder to parse. It takes a lot more mental RAM to understand what's going on here. And this isn't just me saying, this is the J2Objective-C developers saying. They explicitly say that this code is a waste of developer time to try to maintain. They say that this code, they literally say that this code is a waste of developer time to try to maintain. Right? And if we look at it, we can immediately see what they mean. I mean, we're turning a one-liner in Java into this whole thing. And why does it have to do that? Why does J2Objective-C do all this? Because it's trying very hard to imitate the the Java behavior in Objective-C perfectly. It's trying very hard to make Objective-C behave exactly like the Java code. And it does this because Java and Objective-C are languages that have some very significant differences. Specifically, they have some very significant semantic differences, meaning their behavior can be very different in some situations. So Objective-C does all of this to make sure that the behavior is going to be exactly the same in every situation it can. Now, it doesn't necessarily have to be like this. We could theoretically have a tool that translates Java code into readable Objective-C code. That would be hard, but it might not be as hard if we didn't constrain ourselves to only using Java and Objective-C. We could technically use any language that can be used for iOS and Android. So for instance, we could use Swift and Kotlin if we wanted to. So this is an empty class called hello in Swift. It's exactly the same as it is in Java. And this would be an empty class called hello in Kotlin. Notice that the only two things that are different here is this internal modifier and this open modifier. This is because classes in Swift are internal and open by default, but classes in Kotlin are public and final by default. So we just add these two words here, and this behavior in the two languages will be exactly the same. So because these languages are more similar than Java and Objective-C, it would be possible to create a translator that turns readable Swift code into readable Kotlin code. And this is exactly what our last cross-platform tool of the list does. The tool is called Gryphon, and it works a little bit like this. It turns readable Swift code into Kotlin code because the languages are similar. They're both similar in their syntax, so they're written in a similar way, and they're similar in their semantics, so they behave in a similar way. It also translates any reference it can for the Swift standard library. So if we use arrays in Swift, if we use map in Swift, if we use any reference to the Swift standard library, it's going to try to translate that into the Kotlin standard library. Meaning our Kotlin code doesn't have to depend on the re-implementation of the Swift standard library in Kotlin. Right? So if we use Objective-C, we would have to link the Java standard library written in Objective-C into our Objective-C code. We don't have to do that with Gryphon because it tries to translate most of the standard library translations. Meaning that the Gryphon standard library actually only has like 300 lines of code, as opposed to Objective-C's several hundred thousand lines of code. So the generated code is simpler, the library that we have to use is simpler, and in some cases the translation is even simpler than the original code, because Gryphon tries to identify all of the patterns that it can find on the Swift code, like this guard let here, and turn it into more idiomatic Kotlin code. So this guard let x equals x else return does exactly the same thing as this x question mark colon return. It checks if x is null, and if x isn't null, if x is null, it returns. If it's not, it goes on. It's exactly the same behavior, but in Kotlin, it's a bit shorter. And Gryphon can identify these cases where the Kotlin code is simpler, or some of these cases at least, and it can do these translations to make sure that the Kotlin code is as idiomatic and as understandable and as readable as it can. So it uses these kinds of techniques to try to make sure that our code is as simple as it can be, as understandable as it can be, and always correct, meaning that it always behaves the same. And because of that, when we try to use Gryphon, we get something like this. We get Swift code that can be compiled directly into an iOS app. We get Swift code that can be run through Gryphon and turned into Kotlin code. And this Kotlin code, if everything goes right, will be readable and it will be understandable. And because it's readable and understandable, if we remove Gryphon from the equation, if we stop using Gryphon, maybe because we didn't like it, we didn't adapt to it, maybe because we want to try something else, maybe because it's no longer maintained and we have to remove it. In any case, if we have to remove it for any reason, what we're left with is a Swift code that we can compile to iOS, we can understand it, we can maintain it, and Kotlin code that we can compile to Android and we can understand and we can maintain. So we just stop using Gryphon, literally. We don't even have to uninstall it, and we can just hit the ground running and keep maintaining our two separate native apps however we want to. So we've essentially removed the dependency of Gryphon completely, right? Our code finally doesn't depend on it at all. So now that we studied the dependency of these kinds of cross-platform tools, let's take a look at how Gryphon works. So I'm going to hop to an IDE now, and I'm going to show you a few examples of how to translate Gryphon, some normal pitfalls that can happen when you're using Gryphon and how you can avoid them, and some things that you should keep in mind when you're looking at the translations to understand what's going on there. Okay? Let's do this. For this demo, we're going to be using Gitpod, which is this online editor, this online IDE here, that is running a version of Gryphon installed in a Docker container. So you can use it at home if you want to just try Gryphon out, see how it works, see if it works for you, see if you can do what you want to do with it. You can try it out on Gitpod without having to install anything in your machine, etc. So we're going to go through a few examples here, some examples to show what Gryphon can do, and some examples to show the kind of common pitfalls that people often fall into when they try to use Gryphon for their code. So here we go. So let's start with a very simple example, all right? We're going to start with just a simple hello world. So how do we write a hello world in Swift? This is going to be really simple code so that everybody can understand it, even if you don't really know Swift that well or Kotlin that well. I'm going to try to go slow and make sure that everybody understands what's going on here. So how do we start with a hello world in Swift? We just type print hello world, and it should work fine, all right? So here we can go run Gryphon and give it this main.swift file that we're using. Tell it to translate. Takes a while. And then it translates our code. Now, we might be expecting it to translate into a main.kt file, but what actually happens is it outputs the translation into the console. Now that's not really what we want. So in order to make it output the translation into the right file, we have to tell it what the file is. So here we go and we type Gryphon output to the main.kt file. Once we give it the output path, we run it again, and there we go. There is our output file. Okay, so this is a pretty straightforward translation. Kotlin needs a main function just like C does in order to run its code. So this print essentially gets translated into this println, right? Println is the print name in Kotlin, so this is basically just the same code. This is how we can make a translation to another file. We just specify the file path using this Gryphon output comment. This kind of comment, it's called a translation comment, and we're going to be seeing a lot of those in the next few examples. They're essentially comments that let us change the way the translation happens and change the way our Kotlin file works. We can do it directly. All right, so let's start looking at a more interesting example. Let's say that we want to create a class, and we're going to call our class person. We're going to give our person a name as a property, and we're going to create a constructor that takes a name as an argument and assigns that argument to the property. Okay, pretty straightforward, object-oriented programming here. We also want to create a method for this class, right? So we want to create a method that's called say hi. And our method is just going to do just that. It's going to print a greeting. We're going to type in hi. Oops. Hi, I'm name. Okay, so this is just string interpolation in Swift. This is how we insert our name property in the middle of a string. So this is going to say, hi, I'm Vini, or hi, I'm John, or hi, I'm whatever. Whatever the name is, that's what it's going to say. And we can call this by creating a person. So let's say we create a person whose name is John. And then we call say hi on that person. Okay, so pretty straightforward object-oriented programming here. And when we try to translate that, here's what we get. Classes are a pretty straightforward translation, right? Because classes work pretty much the same in Swift as they do in Kotlin. So you have your attributes, you have your methods, they're all passed around by reference. So they work essentially the same. Things start to get a bit more interesting, however, when we try to use structs in Swift. So in Swift, a struct is basically the same thing as a class with a few differences. So we're going to create a struct that represents a point, a two-dimensional point in space. And we're going to give it two attributes. We're going to give it a variable called x, which will be an integer, and a variable called y, which will be also an integer. When we try to translate it to Kotlin, we're going to get what's called a data class. So a data class in Kotlin is basically the same as a struct. However, there's an important distinction here between how it works in Swift and how it works in Kotlin. In Swift, structs are always passed by value, while in Kotlin, structs are always passed by reference, or actually data classes, which are the Kotlin classes, are always passed by reference. This, in many cases, won't be an issue, but it can be an issue, and it can be an issue that's hard to detect and it's hard to debug. That's why Gryphon immediately raises two warnings here that we can see down here. It says Gryphon doesn't support mutable variables in value types, and it says that for both our x and our y properties. Why is it saying that? It's saying that because this variable in Swift, it means that the x and y values can change. So we could theoretically create a point. It's going to be, let's say, 0 and 0. And we could change one of the variables of this point. And if that happened, if we did that in Swift code, that could cause problems when it's translated to Kotlin. So Gryphon detects that right away and it warns us right away. Be careful what you're doing there. And the suggestion that it does is, it says it doesn't support mutable variables, so it doesn't support var. So what we can do to simply fix this is change this to a let. And when we do, this works exactly in Kotlin as it does in Swift. If we translate this again, we'll see that the var in Kotlin changed to val, which means it's also immutable now. And we can guarantee that these two files will work exactly the same way. All right, so Gryphon always tries to warn us when we're about to do something that can be problematic and that can cause different behavior. The idea is that any code that's valid, any code that doesn't raise any warnings, doesn't cause any errors, is code that will always behave the same way, behave in a consistent way. Okay, so let's make this struct a bit more interesting now. In Swift, we can make structs do a bit more than just store data. We can, for instance, compare structs. So if we had, again, a point here, and then another point, let's call it point 2 equals points, we could check if both points are equal and then do something. But in order to do that, we're going to need to say that our point is equatable. Meaning our point can be equated, it can be compared for equality. There are a few other things similar to this that we can use. So we use equatable if we want to test for equality, but we could also use hashable if we wanted to take the hash value of this point And these are all things that Swift implements for us, right? So we don't have to actually implement a function to compare if 2 points are equal. We don't have to actually implement a function to tell us what the hash value is. Swift already does all this for us. Unfortunately, Kotlin also already does this for us. We don't even have to do anything in Kotlin. So this code in Kotlin is already valid code. It already has this equatable and hashable that are implicit here. So in this case, we don't even have to do anything. And Gryphon knows that we don't have to do anything. So it doesn't add the equatable and hashable in Kotlin, which would cause a bunch of errors. It also detects when we try to use things that we actually have to implement by hand. So if we wanted to use, say, custom string convertible in Swift, we could do that. Custom string convertible is the protocol that we implement in Swift that lets us specify a custom description, a custom string that describes our point. So to do that, we do var description is a string, and we can return, for example, x, comma, y. Right, so all this means is that if we create a point 1 and 2, and then we do point.description, then we're going to get the string 1 and 2. That's all that means. Now, this is the way that we do things in Swift, but it's not the way that we do things in Kotlin. Kotlin doesn't really have custom string convertible, and it doesn't really have a description. What it does have is a toString method, which is the same thing that Java has. So Gryphon knows that, and it knows that while Swift is going to automatically look for a description variable, Kotlin is automatically going to look for a toString method. So it converts it to a toString method. It keeps the same string on both of them, so that both of them have the same behavior, and so that everything works on both languages. So this is something to keep in mind. If you're ever trying to use a description in a Kotlin class that was translated and you can't find it for some reason, keep in mind that Gryphon tries to do everything idiomatically in Kotlin. So it's going to try to do it the Kotlin way every time it can, and not the Swift way. Okay? Something else. Remember when I said that this Gryphon output was a translation comment, and that we were going to use translation comments in other cases? We can use a translation comment here. So for instance, let's say that we wanted to make Swift print 1 and 2 for this point, for a point that has x equals 1 and y equals 2. But we wanted to do it differently in Kotlin for some reason. We wanted to have parentheses in Kotlin, for example. We could do that by changing this string in Kotlin, right? We could do that if we had this string had parentheses around it. The way that we do that, the way that we have a string or any expression actually be a different value in Swift and in Kotlin is using a comment called Gryphon value. So basically we're specifying the value that Gryphon's going to use for this expression. And we're going to say use the value that has parentheses. Use x and y, but do that in parentheses. So when we try to translate this, Gryphon's going to notice that we added a Gryphon value comment, and it's going to translate it accordingly. There we go. So now we have the Swift code working in one way, where there are no parentheses, and the Kotlin code working another way, where there are parentheses. Right? So Gryphon value comments and lots of other translation comments can be used for this, can be used to customize your Kotlin code to be however you want it to be. And they don't just work by changing values in your code. You can also do other things. For instance, if you're using Swift code to create an iOS app, then you might have a function that should only be called from iOS. So you can have an iOS only function. And it might use iOS only API, so it might use some Swift UI code here or whatever, anything like that. If we want to implement this function in a shared file, like this one, in a file that we're translating, then we're probably going to want to tell Gryphon to ignore this function, right? We don't want this function to be translated because we know that it's not going to work because there's no Swift UI in Kotlin. So what we're going to do is we're just going to comment it out. We're going to say Gryphon, ignore this function. Oops, ignore this function. And when we try to translate it, this is what we get. Nothing. We get exactly the same code that we had before. So Gryphon is noticing that we told it to ignore this function, and it's ignoring this function. It's not going to show up in Kotlin. And we can do the opposite. We can omit something from Swift, and we can insert something new into Kotlin. So we could come here and say, Gryphon, insert this code into Kotlin. I want it to be a function, Android only function. And I wanted to use, I don't know, Android room code or whatever, any Android code and any Android only code. And this should only be valid Kotlin code. Gryphon doesn't even look at it. So we're using fun because it's a Kotlin function, and we could do whatever we want to here. This doesn't have to be anything with Swift. And when we try to translate it, we get our Android only function, but as an actual function, right? This isn't just comments anymore. This is a function that works in Kotlin and gets compiled and can be called from wherever. Okay, so these kinds of translation comments, and these are just a few examples, there are others that we can use, can be used to customize our Kotlin code to be exactly the way we want it to be. And in particular, to mix platform-specific code with translated code. So we can mix and match it however we want. We can insert these comments in the middle of Swift code, and we can do them top level wherever we want. They're going to work either way. Okay? So let's go to a new example. So let's say that we have an enum called direction, and we're going to do north, south, east, and west. When I translate it to Kotlin, it's basically a Kotlin enum, right? Kotlin enums are called enum classes. They're usually done with all caps, so Gryphon's going to translate this as an all caps enum, and there we go. Basically what we would expect from Kotlin code. What's interesting here is that we can also do some new translations with this, some interesting translations with this. So we can create a direction, direction dot east, for example. And then we can switch on this direction. So we can do switch direction, which is basically the same thing as it is in C, for those of you who know C. We could do, if it's east, then we want to, I don't know, we want to print east. And, and if it's anything else, then we want to print something else. Where does this get interesting? Swift can do this, but it can also use a switch to create a variable, to initialize a variable. So we can have a variable here that's called, I don't know, is east. And it's a Boolean. And we can do, if it's east, then it's true. If it's not, then it's false. Then it's false. This is also the kind of thing that Gryphon knows how to interpret. So it knows that this is basically just a variable instantiation. We're just instantiating the is east variable and saying that it's true in one case and it's false in the other. And this becomes, these 7 lines of code over here, they become just these 4 lines of code over here. Because this is the way that we do things in Kotlin. This is the idiomatic way of doing the same thing in Kotlin, right? So in Kotlin we have this is east equals when. When is basically the same thing as switch, but we can use it as a value. We can use it to instantiate a variable. And this becomes just a lot shorter than it would be in Swift. Okay, so again, these are the kinds of translations that Gryphon knows how to do. It's going to try to do them whenever possible, but when it knows it can't, it's just not going to do it. It's going to keep her original code. This can be done, these kinds of translations can be done when we're trying to make Kotlin code easier to read, but they can also be done when we're trying to let Kotlin access some functionality that Swift has, but Kotlin doesn't have. Right? So the other way around, it's easy. When Kotlin has something that Swift doesn't, we're just going to have to implement it in Swift anyway. But when we're trying to use something in Swift that Kotlin doesn't know how to do, then Gryphon sometimes can step in the way and teach Kotlin how to do it. So let's take this direction enum and take it a step further. So we're going to say that this direction enum is a string, right? So it has what we call a raw value of string. This basically means that saying the case north is the same thing as saying it's the string north. And we do this using the raw value. So we could do this by calling direction with the raw value east. And we're passing it a string because we're saying it has a string up here. And we could also do this and we could also access the raw value property directly. Now this is something that Kotlin does not know how to do. But Gryphon's going to teach it how to do it. Gryphon's going to declare the enum, but it's also going to declare the constructor, and it's going to declare the variable. So that we can use it exactly the same way that we use it in Swift. So here's declaring a constructor. It's declaring it as an invoked variable so that we can have the same API. So we're going to have direction east, just like we do here. And it's declaring the property or the attribute of raw value, so that every time we access this raw value, we get the appropriate string, right? So this would be the east string here in Swift, and this would be the same thing in Kotlin. Okay? All of these information and a lot more is available at the tutorials in the Gryphon website. You can go up here in tutorials and it tells you how to install Gryphon, how to translate command line programs, how to translate apps, and how to use arrays, how to use translation comments, how to use some advanced concepts like templates, how to use Gryphon with an existing app. So if you already have an app that uses Swift and Kotlin code, then you can use Gryphon to translate it. You can use it piece by piece. You don't have to do it all at once. You can start with a single file here, another file there, and slowly build your code into something that can be translated automatically. Okay? So now that we talked about Gryphon, is usually the time when somebody asks me, but what about UI code? Can we translate our whole UI? Can we translate our whole Swift app? Can we do this, this, and that? And the answer usually is Gryphon isn't perfect. It can't do everything that you want to do. And it's not meant to do everything that you want to do. Right? Gryphon is just one alternative that you can choose from several cross-platform tools. Right? So it's important to keep in mind with Gryphon, as with any other cross-platform tool, that it always depends on your team and it always depends on your app. So you should definitely use Gryphon if you want something that's risk-free. So if you never used a cross-platform tool before, or if you want something that you know you need to have direct access to native code, or if you're worried about dependencies, which maybe you should be, or if you just want to develop Swift code, you can always use Gryphon. But maybe you also want to share your UI code. And for that, maybe React Native is a better choice for you. Or maybe you just have this really good Dart library that you want to use. And for that, maybe you want to use Flutter. Or maybe your team is just really good with C# code. There's some really good C# programmers that you want to use. Go with Xamarin. The choice of which cross-platform tool to use is always up to the team and depends on the app that you want to use. The point of this talk was to introduce everybody to Gryphon and to tell you all to keep in mind the dependencies of your code, because this is a problem that was already faced by real live companies, and it was a costly problem, and you don't want to fall for the same pitfalls that they did. If you want to know more about Gryphon, you can check it out on Twitter, or you can take a look at the website that I showed you earlier. Thanks a lot for listening, and if anybody has any questions, feel free to ask them.